Stanford Problem 11, which deals with a certain kind of series, and which we can see here. Observe that the value of 1 by 2 factorial plus 2 by 3 factorial plus 3 by 4 factorial plus etc. plus n by n plus 1 factorial is 1 by 2. I mean, sum of the first one term is 1 by 2, sum of the two terms is 5 by 6, sum of three terms is 23 by 24 for n is equal to 1, 2, 3 respectively. Guess the general law and prove your guess. This is the problem. The solution here now, from the expression given above, we have for n equal to 1, that is 1 by 2 factorial equal to 1 by 2, which can be written as 1 minus 1 by 2 factorial. Okay? And for n equal to 2, we have 1 by 2 factorial plus 2 by 3 factorial equal to 5 by 6. It is a given. 5 by 6 can be written as, how we can write down? 1 minus 1 by 3 factorial we can write down, and for n is equal to 3, 1 by 2 factorial plus 1 by 3 factorial plus 1 by, not 1 by, this is 2 by 3 factorial, and this is 3 by 4 factorial equal to 23 by 24, which can be written as 1 minus 1 by 24 means 1 by 1 minus 4 factorial. And thus in general, from these four values, four expression, from these expression, the general law which we can guess as 1 by 2 factorial plus 2 by 3 factorial plus 3 by 4 factorial plus etc. plus, what is that? N by n plus 1 factorial equal to 1 minus 1 by n plus 1 factorial. This is the general, this is our guess. Now let us prove our guess is right, which we can prove our guess. Thus by induction on n. Now assume that the result is true for n, that is 1 by 2 factorial plus 2 by 3 factorial plus 3 by 4 factorial plus etc. plus n by n plus 1 factorial equal to 1 minus 1 by n plus 1 factorial. N plus 1 factorial. An inductive hypothesis. And let me call this as equation 1. That is the inductive hypothesis. Now consider the left hand. Now consider for n plus 1 and therefore that is 1 by 2 factorial plus 2 by 3 factorial plus 3 by 4 factorial plus etc. plus n by n plus 1 factorial plus n plus 1 by n plus 2 factorial. And now you can see by inductive hypothesis or by 1, you can see here. Up to this term and is equal to 1 minus 1 by n plus 1 factorial, okay, plus n plus 1 by n plus 2 factorial. This is by inductive hypothesis. That is by 1. Now you can simplify this sum as LCM is, what is that, n into, which you can write down, n plus 1 factorial into n plus 2 factorial, and this is n plus 1 factorial into n plus 2 factorial minus, for this, n plus 2 factorial plus, for this, n plus 1 into n plus 1 factorial. And now this is equal to, which I can write down this as n plus 1 factorial is there, 1 plus, and this I can write down n plus 1 into 1 plus 1 factorial into n plus 2 factorial minus n plus 2 into n plus 1 factorial. This term can be written as this one, plus n plus 1 into n plus 1 factorial, and divided by n plus 1 factorial into n plus 2 factorial. And now this is equal to, now you can see there are, in the numerator there are 3 terms. Out of 3 terms, n plus 1 factorial is a common factor. Therefore, I can write down n plus 1 factorial into bracket n plus 2 factorial minus n plus 2 plus n plus 1. This I can write down as, because I have taken n plus 1 factorial as a common factor. So I can write down this as n plus 1 factorial into n plus 2 factorial, which we can write down as n plus 1 factorial into n plus 2 factorial minus n minus 2 plus n plus 1. And this minus n, plus n and minus 1 is getting cancelled, which you can write down in the denominator as it is n plus 1 factorial into n plus 2 factorial, and that equal to n plus 1 factorial into n plus 2 factorial minus 2 plus 1, that is minus 1, divided by n plus 1 factorial into n plus 2 factorial. And now this n plus 1 factorial and this are getting cancelled, and what remains here is equal to n plus 2 factorial minus 1 divided by n plus 2 factorial, and that equal to n factor plus 2 factorial divided by n plus 2 factorial minus 1 by n plus 2 factorial, and that equal to 1 minus n plus 2 factorial, and which shows that our guess is true for our guess is true for n plus 1 also, and hence it is true for all n. And this is the proof of the general law.